With this instrument, I'm able to identify exactly what carbon-containing molecules are in a piece of particulate matter, and that's like putting a name tag on that matter. It's like telling us where it's come from. And this instrument, for the first time, gives us the capabilities of doing that in almost real time. And in that instrument, it contains everything that the instrument needs to make these measurements. And so it samples air, polluted air, for 45 minutes or so at a time. At the end of that time, those particles are desorbed off of a filter into a device that both separates the compounds out from one another. And then we have a miniature mass spectrometer, a new invention, another one that came out of BYU called a toroidal ion trap, that allows us to measure to mask the charge, or in other words, gives us a better identification of what it is that's exactly come out of these particles. And then we've developed a pretty sophisticated library that allows us then to compare the data that we're getting from this instrument. We can compare it against this library and then put names to all of these compounds that we're detecting. The instrument is contained in this briefcase, a supersized briefcase size, and it is attached to a computer. But the instrument itself is not something you want to necessarily put into a backpack. But with that said, it weighs less than 40 pounds. So the idea is that you put it in a spot that you want to measure air pollution for a week or so at a time, and then you can, with relative ease, pick it up and move it to a new spot and turn it on and start measuring air pollution in that new spot as well. The current technology, the things that are out there in the marketplace right now, are much larger than that. And when they say that they're portable, they're only portable because they put wheels on the bottom of something that you can put into a shipping container. That's not real portable when you have to have a big truck to move the thing around. This will fit into the back seat of a car. It is my hope that every air sampling division in the United States of America would buy one of these instruments. And the reason for that is that this instrument has proven, and we've published a number of papers on this, has proven to really expand the capabilities of an organization that wants to understand where pollution is coming from. You look out at an atmosphere that's got a bunch of pollution in it, and you'd like to know, is it cars that are responsible for this? Is it people that are burning wood that's responsible for this? Is it farmers that may be burning the stubble off of their fields? Who's to blame for this air pollution that we have? And this instrument gives researchers the capability to answer those questions. So it's perfect for communities that want to know where the pollution's come from. It's perfect for researchers to put out into the field. I think it works actually well for even companies that want to know and be assured of where the pollution is coming from at a work site someplace. Right now we can measure the carbonaceous component of particulate matter on an hourly average basis, but we're building a new instrument right now that also allows us to measure some of the volatile organic carbons that are also in the atmosphere. So we're going to be, with the same instrument, be able to get the gas phase pollutants as well as the composition of the particulate matter, the carbonaceous component of the particulate matter that's in air as well, on an hourly average basis, all with the same instrument that's semi-portable. So the ideal partner would be somebody that makes instruments, that wants to add this into their product lineup, especially people that measure pollution. This would be a perfect instrument to add to their lineup of products.